Hello.
Hello.
Yeah, madam.
हां. तर स्टार्ट करूया का?
Okay, चालेल sir. Madam, can you see my screen now?
येस सर.
Okay, let me make it. Okay, now I hope you can see my entire screen.
स्पीकर नाही.
Yes, now you can see, right?
येस. ओके ओके.
Okay, okay, perfect. So, good afternoon, everyone. I hope you enjoyed the first session. I apologize. Probably in the morning I was a bit slow, and then I have to little bit speed it up. But now, hopefully, you understand some of the basics, um, some of the cloud fundamentals. What is the difference between the legacy data center and the public cloud? The second section, what we're gonna focus is on is not only the creating load balancer, auto scaling group, and security, but I will roughly touch the architecture actually. I will draw rather showing on the screen. I will basically go to the whiteboard, let you understand if you want to design any sort of application within AWS, or maybe that application need to connect to different regions, or that application needs to connect to your on-premise data center, how that complete workflow will work, how one server on-prem, which is in your data center, can talk to another server into AWS, how that communication flow works basically. And we'll touch some of the security parameters on whiteboard itself rather than showing on the screen, because if I put some of the screenshot, I think that will go on very high level. Is better I can explain. And then we can go at the end and make the auto scaling lab. It's a big lab because auto scaling is the concept itself is big. There are a couple of things need to be configured, and we'll see how that works at the end. So just to recap what we have in last, let's say, section. Okay, so basically what we have went through is your own data center and your cloud, right? So what we understand in the first place is when you are building your own data center, you are purchasing any sort of equipment, whether racks, the servers, etc., or licenses. You have to put your upfront cost, which is a capex, from your own pocket. That is not the case when you move towards yourself in the cloud, because you don't need to worry about capex. You only focus on the opex. That means whatever resources you're going to use, you only pay for that resources. If in a couple of minutes, the application takes sometimes months. So that is one of the issue. Plus, if you look at the monthly cost, um, take any service into account is just shut, and there is no billing or there is no consumption of your cost. That is not the case, because once you purchase the equipment, you can't just throw it out. The investment which you have it will be either wasted, or you have to keep it in your inventory without creating any additional benefit out of that. So those are the drawbacks. And as I said, there are pros and cons. The only pros I see when in data center in the past is you have your control, entire control on every system, the servers, the racks. You can mount, you can move, but that is not the case into public cloud, because you cannot touch, you cannot basically visit to data centers. Even if you're a big customer, you and say, hey, I want to visit to data center, that is simply not allowed, because that's in the contract when you sign it. Okay, so now obviously the second day, as per the agenda, we're going to create load balancer, auto scaling group, cloud security. But before I go into more details, I just want to clear your basic again on the architecture. Then it's easy for you to understand how you can simplify and create any sort of auto scaling, or any, you can design any tier 3, which is web application or database sort of infrastructure. So let me put AWS infrastructure architecture first. Hope you can see my screen. So first and foremost thing, like in the AWS, how the structure is. So basically there is a region. You can see my screen, right? The whiteboard.
Yes, sir.
Okay, perfect. So how this architecture within the AWS is, first you need to choose the region, which I told you. For example, if you go to EC2, the first and foremost is you have to choose the region, maybe Mumbai or Tokyo in Japan or something else. Like first you choose the region, and then only you can create any architecture. So that first thing you have to do is select the region. Once you select the region, the second important thing is within the region, there is a concept called VPC, Virtual Private Cloud. VPC, Virtual Private Cloud. And Virtual Private Cloud is nothing but a virtual data center. The data center you already have on-premise, that is a physical. So sort of that data center you create into the cloud, that is called virtual private cloud. Within region, you can create up to 5 VPCs. And these numbers keep changing because AWS keep adding based on the request from the big customers. If you really want more VPCs within that region, you have to request to AWS based on your licensing model and support model. They will increase to the number which you really desire to have it. But just for now, just to simplify, within the region, you need to create a VPC. Within VPC, you have basically application, but that application has first subnet. Subnet, I will let you know what does that mean, just IP subnet. And then EC2 are part of that. EC2 or whether virtual machines are part of that subnet. So this is basically the architecture stuff it is. Now you might be asking, hey Amar, you mentioned region and availability zones. Obviously that availability zones and VPC I'll touch when I'm drawing the architecture. You will clearly understand how the AZ will part of the region when I draw the architecture now. Let me push this a little bit down. Now, if you think about, first, let me take Mumbai as a region. So if I draw like Mumbai as a region, and maybe I draw another region in America, just for an example. Virginia, North Virginia. And maybe I'll draw, this is AWS, and this maybe I draw another customer data center, which is your own data center, customer data center, DC. And you have, let's assume that you have database server here. And that database server, you need to migrate to Amazon Web Services. Just an example. And how that entire communicative would work. Maybe this database, initially, if you want to connect to another server in North Virginia, and maybe there is another server which is in Mumbai, and how they can communicate with database, how we can simplify that architecture. So, as I said, the first is the region. So what we have done is now we have chosen Mumbai as a first region. Under Mumbai, obviously there is availability zones, etc. But I will let you know the how availability zone works. But first understand the architecture. So region, then VPC. Sorry for my drawing, but the VPC, and within the VPC you have subnet. So this is my subnet 1, this is my subnet 2. And subnet is nothing but an IP subnet. So for example, 10.0.1.0/24 is one subnet, and another subnet is subnet 2, just an example, 10.0.2.0/24. And my entire VPC, which is this VPC within that Mumbai region, is 10.0.0.0/16, because I can break this big network into multiple subnets. And within that subnet, I will put my EC2 instance. And EC2 instance is nothing but where you have built an application. So maybe this is my web application, and this is my, let's say, application X. Just an example. So there are two subnet, two different EC2 instances. Now, let's assume that I want this database to be connected from my on-prem data center to my EC2. So AWS has two solutions actually. They have two solutions to connect to your on-prem data center. Either you can create a VPN, virtual private network, where there is a VPN router here on the VPC. Sorry, VPN gateway. VPN gateway, you create VPN over the internet, and you also have to have VPN here. So that means the traffic between your VPC and that on-prem is completely encrypted. So even if the hacker wants to snip your traffic, they cannot see the real traffic. Real traffic in the sense the real IP header, which if say hello, they will not see hello. They will see something like 123 hash or something like that. That is one way of connecting from your on-prem to AWS. But this is again the problem with the VPN is you only have the 1 gigabit per second speed. But let's assume that your database is big and your application really need to carry bigger traffic than 1 GB. You will be connected with direct connect, which is a lease line. Probably you know the lease line like MTNL or BSNL, they provide, and maybe Bharti, which is Airtel, they provide direct cable or direct connectivity, like from 10 Mbps to 10 GB gigabit per second. But obviously this is very expensive. This is cheaper because you already have the internet. You're just creating VPN that less costly than basically paying this. I think in India this cost somewhere around 60,000 a month. Depends on the speed, of course. But this is one way to communicate. And then you route your traffic from the router towards this router and back forth. So this is one way you connect your data center to Amazon Web Services cloud. Now let's assume that I have done this connectivity. I will attach this network to my VPN gateway or attached to my direct route, there is a route table, and that application will communicate to the database. Now, the similar way, you have another region, and there is another, let's say within the VPC, there are another EC2 instance. Now you might be thinking, hey Amar, I need to create the same communication channel like VPN or direct connect to my database data center. No, you don't need to, because there's a concept called VPC peering. VPC peering. That is a connectivity internally between two regions but two VPCs, and you just do both sided. Not only one sided, both sided. You do peering from one to another, and that way it all, because it should be bidirectional, then only the traffic will flow. Once you do the internal peering, then what happens, you basically use that link to connect to the EC2. So you additionally don't need to pay extra cost connecting to your data center. This is just internal communication from data center to your public cloud. But obviously, this is general setting I just mentioned. Now there is an additional security part, which I haven't told here. So there is a concept called security group. A security group is nothing but a firewall. A security group is nothing but a firewall. So in the past, before I touch the security group here, any questions so far before I little bit touch to the firewall? Any question, any concern? Okay, so you're still here. Okay, look, assume that there is no question. So security group is nothing but a firewall. What does that mean is, let's assume that even it is a customer database, right? Let's assume that there is a firewall here, because this is customer and they have FortiGate or any Cisco firewall, and this is an internet where, let's say, Amar is trying to connect to their database, just an example. So what happened when I'm coming from the internet and trying to access the database, I cannot simply access the firewall, which is a wall between the external network and internal network. That's the reason it's called firewall. It's a wall between internal and external. So internal is more protected than external, because hackers, everybody's on the same traffic. Internal only allow to the legitimate users, like Amar is an internal admin of that company, so Amar can only access. But then what happens on the firewall, they only open the specific port. The port is nothing but a database port. If it is a Oracle database server, then it is a TCP port 1521. If it is a SQL server, then there is a 3306. There are different ports which are by default to that particular vendor, like Oracle 5121, SQL 3306. So that port is open on the firewall. The same way, Amazon Web Services changed the name from firewall to the security group. So exactly we have to do here. If let's assume that this EC2 instance, or let's say database, wants to connect to this application X, and this application port number is, let's assume that TCP 1111. So here I have to create a security group coming from X as a source, reaching to that server by opening TCP port 111. Then only that database server will connect to this, even if there is a routing in place. Routing means I can reach this by making ping connectivity, but then I cannot connect on that application if the port is not open, and the port is only open by creating a security group. The same thing, even if these two virtual machines are in the same VPC, by default they cannot talk to each other. The communication is blocked. So to make that communication from this application to this, again you have to understand this application port. Let's assume that TCP 2222. So you have to again open a security group or a firewall port, which is TCP/22, from this as a source to the destination. And that is how the security internally, which is firewall, which is stateful inspection. What is stateful inspection? If the traffic is coming inbound, which is allowed, traffic going back is by default allowed. So you don't need to open two-sided security groups. That is called stateful inspection. I hope I'm not making complicated. Now, this is simple, right? You create VPC, you create subnet. Obviously, in the VPC, you have the big subnet, and then you create the two subnet part of that big IP network, and then you just create VPC network into that particular subnet, actually, .1, .0, 2.0, and then make a communication simplification. So for example, database want to talk to the EC2 here or EC2 into North Virginia, you just make that communication possible. Again, you have to do the same thing, security group, open that particular port number, TCP/3333, for example, and then the communication is possible. This is how roughly works, right? But this is one simple architecture. If what happens if you want auto scaling group? Let me push this little up. Any doubt here before I move this one up? Any question or any question on the chat? Let me check. I'm assuming there's no question. Okay, so if there is no question, then I'm fine going back to the whiteboard. So let's assume that now I'm not taking two different regions. I will redraw again one region without connecting to the on-prem, just simple application within AWS. So like, let's back to again Mumbai region. So this time I'll take some different color. So let's assume that this is Mumbai region. I create a VPC. Sorry. Let's do Control C. And then there is a VPC here under that region. What I want to do is I want to create, this is, let's say 12.0.0.16 0/16. Just another example. This is my entire VPC, and within that VPC I'm creating two subnets. Subnet 1, which is 12.0.1.0/24, and another subnet 12.0.3.0/24. Now, what I'm trying to achieve is a couple of things. What I want at the end goal as a part of auto scaling group is a user who wants to connect to the subnets or EC2 here. This is, let's assume that this is my AZ1, this is AZ2. Now you will see, understand within the two data center, I made it as a one because I'm combining everything. Even if there is another availability zone where my instances are running, AZ3 for example, I'm combined or clubbing them together. That is called virtual private cloud. That means the end user who's coming and hitting to the load balancer and load balancer hitting to the VPC or a target group, they don't know basically. Obviously, there are servers connected here, but they don't know what is my servers are, what their IP internal IPs are, and which server they are connected to. Server 1, 2, 3, 4, 5, or 6. They don't know. They only know that okay, this is an application X, and I'm just connecting the application because on the load balancer I see the end user on the internet, he will see that okay, I'm connected to the load balancer, which is a public IP, and the load balancer is balancing the load on all the servers behind the scene. And this is the internal IP of the load balancer, and this is the public IP, which is the external IP. So what load balancer also does here, he is a security device, another security device. First, it balances the load between all the traffic. So for example, if this server is 80% occupied, this is 20% occupied, this is 30% occupied, let's say 20% again, 70%, and 30% again. Just an example. So load balancer is very smart device which also do health check. Health check means it also check which server, because you configure a sort of a condition that if my load on the server is more than 50%, please do not pass the traffic to that server, rather pass to another server. That is, so let's assume that load balancer functionality before we configure that scaling group. So first, what load balancer does, can someone mute please? I think someone is muting. Is it possible we can mute this person? Okay. So what load balancer does actually behind the scene is, first, an internet user wants to connect to the application. First, what it does, it hides server IPs. Because he's coming from the internet, and the load balancer, which another network is part of this 12 network. So basically it hides all the IP address of the servers. Obviously, load balancer load balance the traffic. That is the main function, that is for sure. I'm not taking that off. Load balance the traffic. But importantly, it hides the IP. It hides the port number. Because the internet traffic is coming like HTTP, and maybe these servers has another port, let's say TCP 1111. So end user doesn't know what port numbers they have it, because they can do SSH, they can telnet or any other sort, they can try to connect. So that load balancers does. Also load balancers does SSL offloading. I don't know whether you have been to the networking concept. SSL offloading is nothing but you have SSL here, SSL certificate. Sometimes you have to accept the cookies. Probably you type this HTTP yes, the yes is a secure. And that yes is nothing but an SSL certificate. So that S, because generally it is HTTP, which is a plain text. But if it is S comes, that is nothing but a SSL certificate is installed on the load balancer. In the past, what I think like 25 let's say 20 years back. No, I wouldn't say 25. 20 years back, this SSL certificate where customers were installing on server itself. But the biggest problem when you install on the server is the server has to decrypt and encrypt, encrypt and decrypt apart from doing the application job. That means the performance of that server were degraded. That's the reason those certificates were moved from the server to the load balancers. And load balancer is a secure device which has enough CPU memory to basically process that SSL transactions. That's the reason is the SSL certificate is been installed, always been installed on SSL. Sorry, on the elastic load balancer, which is generally other service product called load balancer, but AWS calls everything elastic. E means elastic, and I'll come to know. I'll explain what is elastic mean. So when the user comes, he basically doesn't see anything, right? Because he accept the cookies. That means we know that user is coming from China, we're coming from India, or coming from US, because all his because once he accept the cookies, we see the location and IP address, etc. And we see that hey, this IP is not part of the network we're supposed to see, then you can block that traffic also. There is another concept called DDoS protection, which also can does, but I'm not going that detail here. So generally, any user, maybe this is one user, maybe thousands of users. Also, what is important on the load balancer is there are some methods which you configure, like round robin. That means if round robin, least connection, stickiness. So these are the methods you can configure on load balancer. What does that mean? Is if it is round robin, means let's assume that you have server 1, server 2, server 3. If the traffic, let's say Amar and two of my friends are trying to connect to the servers with it, right? So first Amar will connect here, the second will connect here, the third will connect here. Again, if there is another person comes, he again go to the first server, the second will go to this. So basically it is round robin. If you configure that way, then the connection will also work that way. But if you configure the system called least connect, that means when a user trying to connect to that IP address, which is external IP, the load balancer will check who has the least connection, and then only that load balancer will pass the traffic to that least available connection server. But the drawback is like over the period of time, he need to figure it out with the health checks that who's having the least connection. So burden is too much, and it's not recommended action to do that. So generally round robin is the preferred option, and there is a stickiness. Now stickiness is what I'll tell you. Let's assume that I am a CEO of a company, or maybe I am a CTO of a company who's a technology guy. And these guys are really important people, right? Because they are running the whole company. They really want to have access. So what we need to look at, let's assume that the CTO and CEO only connect to the server number 5. So what you can do, you configure a load balancer pointing towards that number 5 and put the stickiness configuration along with. That means every time they connect, load balancer never pass the traffic to any of the server. It only passes to that particular server. That's all. If the server is down, obviously the load balancer need to be configured again for another available server. But that is that. Then the question is like, hey, why can't we basically load balance? But the question is how many times these guys check the connection? Probably once or twice, and I'm sure that the server is always available. So this is generally the load balancer concept. And this is what load balancer does. And I think this is very important when we configure auto scaling group. And load balancer is very important part in any configuration. Now let me go back to a slide for a minute to see whether you really understood or not. So if you go, if we come back, like elastic load balancer, which is ELB, how it works is if you have elastic load balancer. As I said, the example which I just touched is internet facing, because the user was coming is from internet and trying to access the application. There is also same elastic load balancer, but he can that elastic load balancer you can also configure in internal network, where the internal servers are trying to connect to other servers, but that needs to be load balanced. So there are two scenarios. So the external users trying to connect to the web servers or web applications, you need to have the internet facing load balancer. That means you need to configure the SSL offloading. You need to have the public IP here, and you have to hide the port number of these two servers. You have to configure the round robin as a service, etc., etc. But you might have internal load balancer where you have web servers. Of course, behind the scene web servers, you already have the internet facing load balancer, but these web servers need to also talk to the application server, um, application servers, which are also need to load balance, because if the one application server is unavailable, the web servers can reach to another application server. But who knows that whether the server is available or not is load balancer, because as I said, the load balancer also check the health check. Health check means IP address by doing ping command, ping IP address like 10.1.1.1, for example, and the port number. Maybe if it is Oracle server, then it check TCP 1521 port number. So he continuously check, and the health check is like 10 seconds. Every 10 seconds, he make hello, 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 and he will check those things to check whether I should forward the traffic based on the availability of that server. I hope this is clear, that what is the same load balancer, but you position in different way. When it is external facing, it is called internet facing, and then if it is internal, then it is internal. There are a couple of load balancing type: application load balancer and network load balancer. And I think before I go and explain to that, maybe I'll come back to the drawing again to make sure you understand what does that mean. I'm sure you all have went through a concept of OSI model. I'm sure you know OSI model, where you have a couple of layers like physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So I'm sure you know this one, but if not, there is a called TCP model as well as TCP IP model and OSI model. But OSI is very important because you need to understand. Let's assume that two data center has two servers, server 1, server 2. And server 1, which is, let's say, web application server, and this is database server, just an example. They want to talk to each other. How that traffic flows. So probably you might have heard the concept called let me first explain and then I'll come back to you. So physical means there is a cable, right? This physical means a cable connected. So basically the cable is connected, which is physical media. Then MAC data link layer is a MAC address. So every server has a, as I told you this morning, there is a network interfaces that comes with a MAC address. But MAC only understand by switch, which is connected to internal data center. The more important part on the internet when you route is a network. There is an IP address, which I just said, like 12.0.1. network. This IP comes in the network section, where there is a concept called router who does routing for the IP network. switches does MAC addresses. Then if you go little bit up, transport, which is a firewall that understand TCP and UDP traffic. And obviously this part is an application where you have database or Oracle and the application, etc. So when an application where let's say this S1 and sitting on the other side, it basically what it does, it goes down from all the layer and goes up to the other side. And over the period of time, what it does, it check what's the IP I want to communicate, whether that port is open or not. And if it yes, can I communicate to that particular application? These are the things is been verified within that. And that is the reason, if you look at, as I said, there are two type of load balancer, which is application based load balancer and network based load balancer. And this concept where it comes is like this. When I say application load balancer, means that load balancer sit in layer 7 versus application, network load balancer sit on layer 3 and layer 4. So if you look at layer 1, layer 2, layer 3, which is network layer, and layer 4 is a transport layer, which is understand TCP, UDP traffic. So now when somebody really want to configure EC2 instances, I know this is little bit difficult to understand for you, but let's assume that I want to connect to my web server, which is a EC2 instance coming over the internet. I'm the user and wants to connect to that EC2 or a web server. Let's say web server. I'm coming the internet. Basically, this is an application, right? Web is nothing but an application, which is STTP or STTPS. So then in that case, what you need to select is you have to select application load balancer, not the network load balancer. That is the difference I really want to let you know by drawing that OSI model. But behind the scene, how it works actually. As I said, there are two availability zones, right? If you come from the, let's say, CNAME, let's say acpatildemo.com. Initially, what happens, there is a DNS, domain name services. And domain name services is nothing but people can remember AC Patil as a name, but they cannot remember the IP address attached to that AC Patil because nobody remember the numbers. That's the reason the FQDN, which is fully qualified domain name, is easy to remember. So when I type acpatildemo.com, what it does first, it first go to the DNS service of AWS. The DNS check where the public IP resides, and that public IP reside, as I said, SSL when you configure, that public IP reside behind the load balancer. So here. So the DNS basically and the traffic is diverted to the load balancer, and load balancer check, hey, you know what? I want to forward the traffic to the available server within the availability zones. And this load balancer, which is sitting on top of the availability zones, act as a elastic load balancer within that region. Because now there are two availability zones, there might be three availability zones, because maximum you can have three availability zones where additional two servers can be sitting. Now, that is what the configuration you need to do when you design an application, that make sure that you choose minimum two availability zones and allow the traffic to, because even if you have multiple servers in the availability zones, and then on top of that, you have the load balancer, but what happens if the complete data center is burned out or flooded or anything? There is no server where you can route the traffic and user get timeout or any kind of error message. That's the reason you need to design application in such a way that you segregate your servers in a different availability zones and then design that architecture so that even anything goes off, you still have services to offer to your end users or customer. Clear? Okay. There is another concept. This is horizontal scaling, by the way. Horizontal scaling means if I have one server and if that server is going off, by default with the auto scaling, it will create similar server with the same size. That is called horizontal scaling. But vertical scaling is what? For example, I have the server, and what I do, because if there is a performance issue or something goes wrong, I create, this is one vCPU, 1 GB. What I do, I add additional capacity into the existing server. That means I make it add 1 GB CPU and 7 GB RAM extra on the existing one. So either I choose the same or maybe take another instance. That means what I'm doing, I'm just making bigger size to the instance, but I'm not basically replicating the same instance 3 times without any problem. Sorry, without any manual configuration. But if you look at the horizontal scaling, what happens? You have the EC2 instance, T2 micro, which I said, you will have the similar instance. So what happens? If you want to make a horizontal scaling, you have to put those 2 servers into auto scaling group, where you have a setting like minimum, keep minimum 2 servers, keep maximum 2 servers. Maybe keep desired 3 servers. So you configure in such a way that whenever one server is unavailable, by default it create the capacity which you just configured, minimum, maximum, and desired. And like I said, if one server available out of that, let's assume that the one server is unavailable, it will add additional 2 servers automatically. And customer or end user doesn't notice it because they still get the access to the application, and that application will work without any problem. Now the question is, when would you configure auto scaling group? Let's assume that I'm sure one of you might be doing shares, right? Purchasing shares, selling shares in the morning, like trading in the morning, right? There's a Bombay Stock Exchange in Mumbai. People might be buying shares and selling it. Maybe they get up at 9 o'clock, 10 o'clock, whatever time they start the Bombay Stock Exchange. You might have noticed that Bombay Stock Exchange, the trade runs for a couple of hours. But when it starts, there are millions of people try to connect to that website for buying and selling the shares. But think about it, just take an example between 10 and 1 o'clock. After 1 o'clock, they basically, there is no trading happens. So after that, the capacity is not needed. So when you configure auto scaling group, you need maximum capacity when there is a peak traffic. That means between 10 to 11, 10 to 1, you should have maximum server to basically serve the traffic to the end user. And when 1 o'clock, then you configure in such a way that if there is no traffic, remove these 2 servers and keep minimum 1. When next day you hit 10 o'clock, the traffic, battery automatically additionally add 2 servers. The advantage of this configuration is you save the cost, because you only utilize that particular scenario when you need it between 10 and 1, and from 1 till next morning 10, you don't need those 2 servers, so automatically be shut. As I said, this is hourly based charging, where you don't need to worry about those extra 21 hours. You only pay for 3 hours. Daytime, more request comes. Nighttime, no traffic. Instances get reduced, so it reduces the cost. That is the simplicity of this auto scaling group. Now, obviously, there are a couple of scenarios. Traditionally, we had like load balancing, and then you have EC2, but there is without auto scaling. But AWS has added auto scaling, where you have the minimum, maximum desired, where you set like a launch template, and that launch template will help you to spin up additional EC2 instances when there is more traffic. Any question on this so far? Just take a pause of 10 seconds before somebody raises the hand. Or I'm super clear. Okay, I'm assuming you understand everything what I'm telling, which is good news. So let's move on then. Horizontal scaling. So what I'm basically going to do is, first, as I said to you, like I'm going to create a VPC first. So let me put some of the numbers here. So if you look at first, I'm creating VPC. Then once you create a VPC, as I told you, under the VPC, you start configuring. Obviously, I want the traffic should be coming from internet. So the second thing you do is create an internet gateway, attach that internet gateway to the VPC. Once you do that, you create subnets within that VPC. So as I said, 12.0.3.24 or 12.0.1.0/24 under that big subnet, I will create. Once you create that, you need to put those subnet into a launch group. The launch group needs to route a traffic towards elastic load balancer to go out, and then same way, once it's coming traffic from outside to the load balancer, you divert the traffic to the launch group so that it will go to the EC2. Obviously, as I said, these EC2 instances I will not be configured manually. Rather, I will be setting within the launch or target group. I'll be putting the launch template that specifies, hey, you know what? You create this EC2 in such a way that if there is a traffic, make it maximum 3. And there's no traffic, make it minimum 1. But what I need in the desired state is minimum 2 should be available. And that basically creates an auto scaling group. And let's try to configure that. It is a long process to configure because you can imagine you need to create a VPC, you need to attach a internet gateway, you need to create route subnets into that VPC. You need to create a launch template. You need to route traffic towards internet gateway, towards load balancer, and same way from load balancer towards launch group. So a couple of configurations. So bear in mind and look how the configuration is. But any question before I go into the configuration? Do you understand this particular architecture? Yes, no, any question? I'm not sure whether people are really, please ask the questions because this is very important. Huh? I know this cloud is not easy, it look like, but first, if you don't understand small concept before you configure, design, because in the end, it's not about teaching to the students, but also if that subject as an autonomous organization, if you are creating this knowledge base to the students, they really go straight away on their job, and this instead of working as an engineer, they can start working as an architect. I think this is an architectural level sort of discussion now. If it is too much detail, I'll don't go into configuration, but let me walk you through again back to the console. So if you look at now, I'm back to AWS. Let me go back to the normal to make you understand. Okay, this is how you see. Let me first put Virginia. First and foremost, you choose the region. The second thing is, as I said, the first thing you have to do is create a VPC. Let's go one by one as per this diagram. First, setting up the VPC. I'm going to create the VPC first. Let me go and search first VPC. VPC is isolated cloud, which is like virtual cloud. That means one VPC cannot talk to another VPC, as I said, unless you make a VPC peering. They will not talk to each other, right? You might have understood here. You cannot, sorry, what I'm doing. This VPC1 or maybe Mumbai VPC or VPC in the Virgin, they cannot talk to each other unless you make a VPC peering between. So even if I'm configuring multiple VPCs, they become isolated to each other. They cannot talk to officially. That I hope you understand. So let me go to the VPC and create a VPC first. When you go to the VPC, first thing is you have to create, because there is a by default one VPC, but I don't want to use default one. I want to create new one. And then you choose VPC only. Name I can take ACP demo VPC. And what you can do is, once you tell the name, then you have to configure IP address. And that IP address is nothing but your CIDR block. So if you look at here, as I said, go back to this whole 12.0.0/16, which is a VPC I'm going to configure. So put exactly the same thing, 12.0.0/16. That is your VPC CIDR. Once you've done that, you keep the rest default and then create a VPC. So one job is done. The job number one is completed, setting up a VPC. Now I have created a VPC, right? So let's assume that this ACP demo VPC has been created. The IP address is 12.network. Forget about this by default one, which we haven't created. It is by default created by AWS. And you see here, it also says whether it's a default VPC. No, because we haven't created. This existing one is default, which by default, if you have account, it is automatically been created. Now, since we have created a VPC, the second thing, as I said, is once you create the VPC, attach the internet gateway, because you want to, that VPC traffic should go to the internet. But how that traffic will go? That go via the internet gateway by attaching to the VPC. So I'll configure the internet gateway and attach to the VPC. So I'll be back again to the internet gateway, and then I click here on the internet gateway under the VPC. So you see, and under the same VPC, you create internet gateway. So click on internet gateway here on the left. Then you need to create new internet gateway, which is I call ACP demo IGW. There might be a couple of internet gateway you can create for VPC, but naming should be easily understandable. So make sure that you choose the right naming conventions. So ACP demo 01. Now, once I create this name, then you need to ensure that you first create this internet gateway and then attach this internet gateway, because you have created the internet gateway now. Where would you attach? You attach to the VPC. So I'll go back and then create action, attach to VPC. Click on attach to VPC. Which VPC? The one we just created, ACP demo VPC. I created, attach it. Now the second job is done. You see attached, right? So that means we have created a VPC, we have created internet gateway attached to the VPC. Now what is third? Third is configuring the subnet. Now, how would you do that? You go to click on the subnet, which is again on the left side, because you're still in the VPC. Everything, if you look at here, is part of the VPC. If everything inside the VPC, that way also they have done, you will find everything under the VPC. So what I do, I go to the subnet and then click on create subnet. So first you choose the VPC, which is your part, ACP domain demo VPC. Then you will see that the subnet setting will start here. So maybe you choose the name like again ACP demo sub subnet 001. Copy that. Sorry. That. Then what you do, select the VPC zone. You don't need to choose that zone. Did I choose VPC? Yes. Then you choose subnet. Let me choose that subnet name in a different fashion. Maybe what I can do, because what I want to do is I will create those subnet into zone A and zone B. Then let me put subnet and 1A. And then choose the 1A. You see, I'm gonna put, because this is the availability zone, sir. So what you do, you give the naming convention in such a way that you want to choose that availability zones. So make sure that 21A and the subnet are matching the names. And then what you can do is give the IP range here, like 12. Because this is the bigger CIDR for VPC. Now I'm creating a subnet. So this is subnet CIDR 12.0.0.0/24. Okay. And now you create the subnet. No, sorry, this is one subnet is done. Now I create another subnet. That means two subnet, one subnet, additional subnet here. So let me create additional subnet. So copy this one because we want to make it 1B. So add new subnet, then give the same name except B. So paste. And then choose the zone which is 1B. Same matching name. Again, you have the 12.0.3.0/24. /24 means you only can choose 256 IP with 200. You can basically build 256 machines or application within that subnet. Likewise, you also do the same thing in another subnet. So if you build, like say, 256 application in that subnet and another 256 application, that means 512 application you can build within two different subnets. That is a possibility, but just additional knowledge for your understanding. And once you do that, then click on create subnet. So now you will see that I have created two subnet 1A, 1B, and their IP ranges and how many IP address available. Generally 256, but 5 IP addresses. Why they have taken? Because there is a DNS IP, the gateway IP, and a couple of reserve IPs. That is what 5 IPs are gone, and the 251 we can utilize. Okay, now we have created the subnet as per the drawing. The next thing is creating a target group. But before we go to the target group, I want to create a routing actually and route table, because this route table, as I said to you, it should go to the Elastic Load Balancer and come back. I need to create some routing actually. So what I do before I create the target group, I create a route table. So if you go back here and click on the route table, again under the VPC, you have to create a new route table. So create a route table, name again ACP. Route table 00. Just select the VPC which we are part of, because everything is clearly said, like this route table is part of that VPC. It's not other VPC, because that's the easiest part you need to remember. Once you create that route table, you just create it, and these route tables are not associated with subnet 8, because if you look at, I have created the route table, but I haven't associated with that subnets, this 3 dot and 2 dot, 1 dot. So what it needs to be done is then go on the subnet association here on the same route table and click on edit subnet association. And then what you can do is the subnet we have just created, you just need to attach this and this, and you just say save association. Because now what happened, those route tables I have attached to the EC2, because now they know exactly where to go and which subnet I take into account. After that, these route tables are responsible for providing internet access. And basically for that, you need to do is create a route actually. So you go to the routes again. I know this configuration is a bit difficult and you will not understand in the first place, because you have to have the understanding about how the availability zones works, how the elastic load balancer work, how the auto scaling architecture work. But I'm trying to simplify in a way that you can easily understand by replicating back again on this drawing. So I'll go back to the routes again. I click on again edit route. Then you have the route to the internet gateway. Edit route, add route to internet, because what I'm doing here, I create the route, but I want to pass all the traffic to the internet by passing to the internet gateway. So route to the internet route to the internet gateway and towards the end user. So that exactly same thing I'm doing. So every traffic going outside, I should forward towards the internet gateway, and internet gateway we have created is ACP demo 001. And once you do that, then you can save the changes. That means now there is a complete routing is properly set up. The EC2 knows exactly how to reach the internet. That part is done now. Now, if you look at the second thing is, this E2C instance is part of the blue line, which is a target group. Supposed to be part of target group, because if the traffic coming from the internet to the load balancer does not directly pass to the EC2, rather it passes to the target group. Because in the target group, there might be couple of subnets, right? Which we have 2 subnets. So if you only forward toward this subnet, then the rest subnet you will not allow the traffic to go to. That's the reason we club that target group into 2 subnets. So now let's configure the target subnet. And the target subnet is where the EC2 instance will be created under the subnet. So this EC2 instance will be connected under subnet, and those instances are part of the target group. When we create a load balancer, that load balancer will be pointed towards the target group, and target group will be pointed towards the EC2. So load balancer target to the target group point toward the EC2. That is how the target group functionality works. Now I need to go to the EC2 instances. EC2. And I need to, as I said, I need to create target group. So I go back on the down where you see the target group under the load balancing, because the target group, which part of the load balancer where you need to point. So that is where it under the EC2 you will see the target group here. So I'll click on target group. You will see as of now there is no target group configure. That is where we need to configure the target group. So I create a new target group. Let me give the name SCP demo. Then what you need to look at is keep the port number as it is, because I want to do the STTP or internet traffic. So I keep STTP. Then VPC, you need to choose it. Here you need to choose the VPC ACP demo. The rest you can keep the same. You don't need to worry at all. And then click on the next. Now you have come to this point, because you see that there is no instance attached here, right? Because so far I have not created any instances under the target group, which that will be done with the auto scaling group. So as of now, I'm not attaching any instances to the target group, because everything I'm going to keep it default. So I will create a target group now. As of now, if you look at here, there are no instances, but the target group look healthy. And later, once the instances will be added, you will see that 2 instances will be healthy. If I shut one instance, it will show that 1 instance will be unhealthy. That we will see that later. So now you see there is no load balancer also attached. So what we can do, next resource we have to create is a load balancer, because now we have created the target group, but now we need to create load balancer and point towards the target group. So what we can do is go to the load balancer. If you look at here, we have the same in the same section. In the same section, we have the load balancer. I'll click on the load balancer. And you have to create a load balancer, because since we are working with EC2 instances, we have to, as I told you, we have to choose application load balancer, right? Not the network load balancer. We can network load balancer only work on layer 3 and 4. Application work on STTP, which is that's the reason when you choose application load balancer. When you choose application load balancer, again you have to give some name like ECP demo and app application load balancer. Again, internal or internet, because since it is coming traffic coming from the internet, I want to choose the internet facing. If it is internal, again you choose this one, but now since I'm coming from the internet, I'm choosing internet one. What the network mapping, you need to choose your VPC, because if you look at here, again you have to choose your ACP domain, and you have to select both the subnet which we have created, right? A1 and A2. You see here automatically subnet created. When I click this one, you will see the B2 subnet automatically been created, and we can attach to that particular scenario. Because when I come to traffic target group where 2 subnets are there, that's the reason I'm attaching subnet 1 and subnet 2. now the security group, I told you, right? Um, there is a security group where it's like a firewall, right? You see, the security group is set of firewall rules that control traffic to your load balancer. So that means if the traffic is coming, you need to understand how what port I need to open. So obviously, if you look at here, I'm coming from the internet and I want HTTP. So I'll be creating a security groups with HTTP open on it. So we need to open HTTP port on the internet facing. So that's the reason we have to create the service group. So if you click, where is that? Because there is no service group here, default one, I don't want to, I want to create. So basically what you do is you create, it will take you to the different tab. What you do is again give the name ACP security group, and what I need to do is I want to open two ports together, STTP as well as SSH. Is I can Linux boxes, I can also add SSH to those boxes. Give some description, allow HTTP and SSL. Sorry, SSH. Then what you do is basically you create, you choose the VPC, and then the full last thing you need to add the rule. Actually, you need to add a rule because you don't want to add outbound rule, you want to add the inbound rule. That inbound rule, you say HTTP traffic coming from anywhere. So basically what you do is source should be anywhere, right? And then what you do, you go and create it. So now I have created the security group which says I'm only opening HTTP. Now the same security group, if you look at this one, I copy for now. It should be automatically available here. By the time it was not showing, right? It is not showing, but if I refresh it, you will see that the security group is now added. So I choose that security group here, as well as the default one. And then I go to the listener port here. And in the listener port, as you know, we have created target group and elastic load balancer, which pointing towards the target group while I'm doing it. So whatever the target group I have created, I will select that target group. The target group is demo 001. Then I go back to summary where I'll see whether it is configured. So if you look at now, before I create a load balancer, I want to see whether whatever we have chosen is correct or not, because you don't want to remove that load balancer again and reconfigure it. Best to check. So check first. Now we have chosen internet facing. Yes, that is what we want. We have attached HTTP SSH. Yes, that's correct. We have created VPC, ACP demo VPC, that's correct, and to subnet, that is also correct. And the port which we want to listen on is HTTP. So all the parameters are correct before we create a load balancer. So I go and hit create load balancer. View the load balancer. It will, now it is in the provisioning state. That might take a couple of minutes to, what happened? Okay, now it is in the provisioning state. It will take a couple of minutes to basically get provisioned. So let's wait for that. Meanwhile, do you have any questions so far? Any question? I know it is a big configuration to make this happen, but these are the steps. Obviously later what you can do also if you're trying yourself, and if you're really like Python expert or Java expert, you can, all the settings which I'm doing, you can code yourself. and then use the cloud formation template, because if you look at AWS, use formation template. Cloud template, AWS. So if you look at this cloud formation templates, which is done by part of the AWS, so there are some sample templates you can use, and you can write some your own codes and own repositories. You can do that, and you can just grab the code and build the same auto scaling group without configuring manually. But since this is the demo where you really need to understand whether you understand some of the parameter, like how to go where the tab is under VPC. If you choose the VPC, everything lies under that VPC rather than outside VPC. So those flow you need to understand first. Now, once the load balancer is created, there are a couple of things like I need to configure auto scaling group and make sure that I'll create a launch template and that launch template part of that, and then probably we are done. So now if you look at, we have created step number 5, which is application load balancer. Now I need to create a launch template, and if you look at the launch template is nothing but I will set up some parameters like keep minimum 1, maximum 3, and desired 2. So if there is a huge traffic, it will expand to 3, but if there's no traffic, it will keep minimum 1, but my desire is 2, so it will keep minimum 2. So 2 will be my desired state, and if I make one instance terminate, by default without adding manual EC2 instance, it will create automatically because of this launch template, because we are configuring these numbers 1, 3, 2, etc., and that way it will automatically provision. Yeah, now if you look at the state has changed from provisioning to the active. That means the load balancer is ready to serve the traffic. The load balancer will serve against 2 availability zones, which is East US East A1 and B, 1B or 1A or 1B. These 2, where if one availability zones or data center is failed, it will reroute traffic to another available server. That is how the way the type is application, not the network, and when we have created today. So now, since we have created load balancing, the next thing is auto scaling group. So again, I go back down, and there is a auto scaling here, and click on the auto scaling group, and then I click on auto scaling group creation. Let me give the name again, PCP demo auto scaling group for EC2, and I'm going to create instances, select for instances. Once I do that, I will go in the launch template. You see there is no template. You can create a new template, because I really want to create a new template. So I go here on launch template, because this launch template, which I just told you, like we have to create a launch template where this configuration needs to be in place. So that's the reason I want to create a launch template under the launch template umbrella. So if I go and configure the launch template, let's say again the ACP demo Apache instances, the launch template Apache. Then I choose an AMI. Version is not important. You need to choose an AMI. So I choose Ubuntu. Let's check. let's choose the AMI. Oh, sorry, Ubuntu. Sorry, not from there. Sorry, apologies. I need to browse this. I need to choose the Ubuntu. $64. Both are eligible, but I want to choose 1 GB. Okay, so I'm going to choose this one, the Ubuntu, which is free tier. Always make sure you check the right one because it is free tier. You don't need to pay. And then I choose T2 Micro because then it is a free edition. Under the key pair, I will choose the one which I have created this morning, which you see that I have created ACP demo. I will choose that same key pair so that I don't need to recreate again. Under the settings, it is very important that there you see like you already created some of the settings. Don't choose any setting. Just mention do not include any launch template because I don't want that network setting to be done by manually. It should be done automatically with the help of the application security group. Auto scaling group. So I don't choose that one. After that, in the security, you can advanced setting. Where is the VPC? Sorry. Okay, perfect. Yeah, so now I go to the network interfaces where you have the security group. The security group which we have created, I think we have named it, right? SG. Where is that? This one, yeah. Okay, that's great. We need to enable port 80 so that we can do request STTP and SSH traffic. So that's the reason I have chosen this security group. This one. Oh, sorry, deattach, which is attached. Make sure that we are not missing any parameter here. Then assign IP address, because what is important here is you have to assign the public IP address. So that's the reason you have to choose auto assigning public IP enable. Then you go to did I miss any configuration under advanced? Yeah, under advanced you basically need to add a script. So what I did, I create a Apache script. I will copy this one, and what it does basically, it runs the Apache, and once automatically the virtual machine is created, it will identify the host name and the IP address. So hope that will take into account. So I am just putting that one, and then you need to create a launch template. 1 second now. Did I miss? I'm thinking with did I miss VPC configuration? Just a second. This ACP pair is created. It's so many configuration settings you need to take into account. That's the reason I'm just choosing the right configuration. Look like we are good to go. Okay. Then now what I do, I will create a launch template. Then I would view the launch template. The launch template is created. Now I go back to the configuration to see whether my launch template is created. Yes. Now I see the instant Apache here. And then I'll keep the version at it as it is. And then click next. I want to choose the VPC ACP demo. Attach the existing load balancer. I don't want to choose in those two needs to be selected. Part of the VPC, go next. Because the existing one which we have created, so I'll choose the load balancer which is created earlier, demo target group. Now, no VPC service, yes. We need to turn on this feature, turn on elastic load balancing health check, because as I said, health check is only possible to check whether the server is available IP or port number. That's the reason you have to tick box that particular setting. Since this health check 300, which is 5 minutes, is too long, so I want to make it 20 seconds. And now click next. There is a health check. Yeah, now if you look at now, when I say we have to check it here, this is an important configuration where we have to put minimum, maximum, desired one. As I said, the desired one, I want to put minimum 2 servers, and in the scaling, I will keep minimum 1 and maximum of 3 servers. Right? That is the configuration we want to choose it. If you look at here, pick 1 minimum, 3 maximum, 2 desired. So 2 desired, 1 minimum, 3 maximum. And then I'll click next. And then I don't want any optional, I don't want tag. You want to review 1B demo VPC. Yeah, I will create the target group. So now the target group is configured with 2 desired, 1 minimum, 1 6. Now I'll go to the EC2. The hopefully it will create 2 instances here. Once that setting is pushed, they will create automatically the instances. Let's see. It's a long configuration, I know that. I'm really apologize, but that is how it is. Let me go to the load balancer actually. And I'm not sure, first of all, the launch instant is done. Let me check first. What happened? Yeah, it takes a little bit time. Now you see that the EC2 instances are provisioned. They are in running state, which is good news. And if you look at, let's note it down on the notepad. There are two instances has been created, which is C8 at the end and 7E. So we'll see how that goes. Now, since the two instances is automatically configured as per our template, like desired should be 2. So if I turn 1 off, it should automatically create additional 1. So let's try that. So what I can do first, before that, I go to the load balancer. Load balancer, and I copy the DNS name, and I go and hit that DNS name here. Just to see that it shows me configuration. Yeah, you see now it says like my Apache is working, it works, and basically I see the traffic is coming, right? Because I configured two Apache servers, I mean all the servers with the script. So this script basically say install the Apache. That's the reason I install Apache and it works. Now you see that there are two servers are already provisioned. So if you look at here, two servers are provisioned, right? And if you go to the ASG application, if auto scaling group, and if you click on here, you will see the desired capacity here, same. And then under the instance management, you will see there are 3, right? Total 3. 1 is unhealthy and 2 are healthy. So now I'm gonna do one thing is either C8 or 7.9, either of the two. I'm gonna make it shut. So let's say C8, I'm gonna shut it down. And once I shut it down, then it should automatically launch additional instance to make minimum desired capacity of 2. So I'll go and C8 and terminate the instance. And just to see the configuration is gonna work, because if you see like this is initializing, that means let's check. So now if you look at the third one, which was not in place, now it is initializing. That means it will automatically, with the script of auto scaling, he will make that server available. Now it is running, but the 2 checks will pass because it is in initializing state. And you will see that server, which is additionally it was provisioned because there was 3 maximum, but the third one will be active and it will be available. And that is how it works. So even if there are instances removed, it will automatically add without your manual configuration. So if you go to the load balancer, ASG, for example, and then you see that 2 desire, 1 minimum, 3 maximum, and you will see that under the instance management, that 2 back again. So 2 were, because first was unhealthy because there was minimum maximum 3, but when I shut, that becomes unhealthy, which is C8. Now C8 is unhealthy because I terminated, but then it basically created new server which is still in pending state, but it will be active soon, because if I refresh, it will be in service very soon. You see now 2 servers are by default in service. That means auto scaling will automatically fire um, two different services based on the configuration we have made it. Yeah, I know it takes time for configuration, but now this is how you need to configure. I will make some document on this, how to configure, and I'll pass it on to you. Now what we learned today is, just before we finish this today's session, the load balancer, our EC2 auto scaling entire group, it helps to do health check monitoring. That means it checks whether the server is available, the application port number is available. It does auto healing. That means if one server is terminated, it automatically spin up additional instance based on their existing configuration, and the configuration with min, max, and desired, it automatically heals. That makes high availability. That means there is always 2 servers available, and that is highly available. That means one is unavailable, there is another server is always ready to serve the traffic to the end users. And this scenario you can run in hybrid fashion. And that is the goal of the EC2, to configure in big setups like multiple availability zones, and then you want to load balancer traffic, especially the web traffic, because the web traffic is coming over the internet, and the backend traffic you don't need to. And the purpose of auto scaling, as I said to you, is saving the cost, because when there's a daytime, you need more requests, then you need more virtual machines or application to serve. If there is no traffic in the night or maybe evening time, you make it minimum of 2. And with that, I think I'm done with the AWS. Obviously, if you really want to know a couple of things, you can figure out yourself once your account, like the additional services like database, compute, container. If you look at the database, for example, DynamoDB, which is nothing but your NoSQL server. And this is fully managed service. That means you don't need to manage about the hardware, you don't need to manage about any scale. It is by default managed for you. You just focus on the scaling database, NoSQL, where whatever capacity you need, you get that capacity. So like I said, the capacity means you can add for the performance. No server to manage, because it's a fully managed service, because they manage for you. That's the reason you don't need to manage the server physically. So, and there are a couple of use cases you can take for DynamoDB, like gaming, because gaming and banking applications where you don't need SQL to face. Then these are the things you can use. Retail, for example, commonly used for retail, because they are the PC card industry, right? They really need to have that retail, let's say, NoSQL data to be, because it might be unstructured or maybe semi-structured, where you can utilize that DynamoDB. Any questions so far? Obviously, you can go to the services, and if you are an IoT-based application or machine learning application, you can figure it out yourself, because there are so many hundreds of services. It is difficult to talk in an hour or 2. Madam, any question? Can we get this PPT? Yes, you will get it for sure later. Apart from that, any question before I close the day? Okay. Thank you. Thank you so much. And have a great day. We'll speak tomorrow.
I think there are no questions, sir. Thank you for such an informative session, sir. We'll be using the same meet link for tomorrow's session also, rather for all the sessions. Okay, sir. Thank you.
No problem. Thank you so much. Have a great day. Bye-bye.
Okay, thank you. Participants' attendance link is shared in chat box.